We have booster ignition and liftoff of Columbia, reaching new heights for women in X-ray astronomy.
The main thing Chandra does is take these superb, sharp images.
When you look at the night sky, stars look like permanent beacons of light. However, stars are born, live for a period of time, and then ultimately die. How they die is directly linked to how massive they were when they were born. Dr. Peter Edmonds of the Chandra X-ray Center explains how stars form over a range of masses.
Stars come in lots of different masses. Some are a lot less massive than the Sun, and some are a lot more massive. The mass of a star determines one very important thing about its life: how long it will live for. The really lightweight guys can live for many billions of years, while the monsters at the other end of the scale live for only a few million years. That might be the opposite of what you'd guess would happen. You might think that because the massive stars have more stuff to burn, that they'd last longer, but that's not how it works. They just burn through their fuel faster and get really incredibly bright. Stars like the Sun aren't nearly as bright, but they live much longer. The Sun has been around for about 4.5 billion years, and it has about 5 billion years to go before it turns into a white dwarf star, a much smaller, burned-out object. In between these two stages, the star will become a red giant and expand in diameter by about 100 times. That won't be good for life on Earth at all, and in fact it's the ultimate global warming, but it's a long way off.
But what about those stars that are much more massive than the Sun? Is the old saying true? The bigger they are, the harder they fall?
The stars that are a lot more massive than the Sun will explode as supernovas. When the fuel in these stars starts to run out, they collapse violently onto themselves because of their huge gravity. In some cases, neutron stars form in the middle, and in other cases, for the more massive stars, black holes are formed. These black holes will swallow up a lot of the remains of the exploded star, and this stuff will be locked up forever. Supernova explosions are the most powerful stellar explosions in the universe, and the brighter ones can be seen across most of the universe. In most cases, the bigger the star is, the bigger and brighter the explosion is, but that doesn't have to be the case if a lot of material is locked up into a black hole. In fact, if all of the exploded material falls into a black hole, then there's nothing left to produce light, and there won't be a supernova at all. That's a pretty disappointing end for a massive star.
But there's a special way for a star to escape this quiet and sad end to its life. For stars that are extremely massive, say well over 100 times that of the Sun, theorists predict that something unusual will happen. Some of the colossal energy is turned into mass, by the old E=mc², and that's fatal for the star. The loss in energy causes the star to collapse under its own huge gravity. After this, runaway reactions cause the star to explode. This spews all the debris from the star into space, without a black hole or neutron star forming. This special type of explosion has been predicted, but never seen.
Just recently, astronomers announced they discovered a new supernova called 2006 GY, and it was the brightest one ever seen. They think it may be the most massive star ever seen to explode, and could be one of these special types of explosions. This supernova was observed with optical telescopes Keck Observatory in Hawaii and Lick Observatory in California, and also by the Chandra X-ray Observatory. The X-ray observations helped confirm that it was the collapse of an extremely massive star. The star was so massive that it was literally off the charts.
So Supernova 2006 GY is making scientists rethink how stars, especially the very biggest ones, end their lives. The study of exactly how stars live and die is known as stellar evolution. Missions like Chandra will continue to gather data that both answers and poses new questions in this incredibly important area of astrophysics. For more information, visit our website at chandra.harvard.edu.
This was a production of the Chandra X-ray Center, Cambridge, Massachusetts. NASA's Marshall Space Flight Center manages the Chandra program. The Smithsonian Astrophysical Observatory controls science and flight operations from the Chandra X-ray Center.